Hello, in this video, we would like to take a look at one of our first Jupyter notebooks. And in the process, we will introduce how to operate within Jupyter notebooks, how to use Markdown and SymPy in the environment together. In fact, I would recommend you getting access to a copy of Jupyter Notebook, either locally installed or through cloud service or through the lab, so you can work alongside the video, which will make the process a lot easier. All right, now let's jump into this file, just demand supply one demand. If we click it in the Jupyter Notebook environment, it's going to open up. Notice now that on top of the Jupyter Notebook, we have a bunch of buttons, and we will make use of some of them in a second. If we look at the first cell in this notebook, we'll see that it is a markdown cell. And if I double click it, it's going to enter the edit mode, which means I can now type whatever I want, say for econ 260. And then if I press escape on the keyboard, I'm going to exit the editing mode. And you can see that this part of the cell changes slightly to indicate that I'm no longer entering anything. So now if I hit my keyboard, it's not going to type anything into the cell. Instead, it's going to work as a keyboard shortcut. And this is going to be useful in a second. Now, to contrast that again, please pay attention to this part of the cell. Now let me double click again. You see that it becomes green instead of blue, and you will see a cursor flashing here. So now if I type again, it's going to enter content into the cell. So now if I press any keys on my keyboard, it won't be treated as a keyboard shortcut that operates Jupyter Notebook, and it will just be treated as you're typing into the cell. Okay, now I'm going to hit escape again, and now I'm no longer entering. You can see that the cursor is nowhere in the cell flashing. I'm not entering any content into it anymore. So now a useful keyboard shortcut we would use is B. And this is insert a cell below. Now if I hit B now on my keyboard, you see that immediately there is a new cell being inserted below the cell that I had. Now let me try that again without using keyboard shortcut. There is a button here on the menu that has this plus key. If you leave your cursor on this button, it's going to tell you that this is insert cell below. I can press this button. It's going to insert a new cell below the current cell you have. Let me again return to the first cell. Another way to insert cell is to choose a particular cell and then come to insert and then choose insert cell below. The advantage of using the menu is that instead of using insert cell below, you can also choose to insert a cell above, like this. Okay, now we have multiple cells, and by the look of it, because we have in on the left-hand side of the cell, it's indicating that this is actually code, as opposed to, looking at this cell here, it's actually markdown. Okay, so how do we change the type of the cell from code to markdown? Well, it's very easy. We just need to come here to this particular drop-down menu, and I can select markdown, and immediately the cell becomes a markdown cell. Now if I double click on it, it becomes green again, and we can type anything we want as markdown. We just say, what if I typed this? Okay, now I'm going to press escape again, but now realize that these texts appear in the cells do not look like these texts. They're already rendered as markdown. So how do I render them? Or in other words, how do I ask Jupyter Notebook to run the cell as some code? Okay, to do that, I just need to press this button, which is run. And now see, it is being rendered. The keyboard shortcut I like to use for run is shift return. So instead of having to click on this button every time, I can just finish editing, let's say for econ 260, and then on the keyboard, I'm going to hold down shift and press return. And now it is being rendered as text, as a markdown cell. Okay, so now after it's being rendered, the Jupyter Notebook will automatically move our focus to the next cell. So now, for me to type anything in this cell, I can left click in the cell, which will allow me to type in it, or using a keyboard shortcut, I can just hit enter. and that will put me into the entering mode. So now I can type 1 plus 1, and now notice this is a code cell. If I run it now, use shift return, it's going to give me an output from the Python engine that tells me the result of 1 plus 1 is 2. Now, what if I have a code cell already, and now I would like to turn it to a markdown cell? Well, we said that one way you can do that is to use the drop-down menu. Another way to do it, to shift between markdown cell and code cell, is the following. When we're not in editing mode, meaning this is blue instead of green, we're not typing anything into it, we can use keyboard shortcut M for markdown. Notice I just hit M, and immediately the cell changed to markdown. And if I hit enter, I type in 1 plus 1. I now press shift enter to run it. It just says 1 plus 1. It does not do any calculation, but instead just renders it into text like these markdown cells above. Okay, now what if I entered these text 1 plus 1 as markdown? However, I wanted to now switch it to a code cell. I can use the drop-down menu to change it to code cell. And then I can now evaluate it. It's going to calculate the result. You can change from markdown cell to a code cell by pressing Y, and that will switch you back to code. Okay, so again, M switch to markdown, Y switch you back to code. For instance, here in this cell, I already have codes, but I can press M, that switches me back to markdown. But if I return here and press Y, it returns me back to code mode. Okay, so these are very handy keyboard shortcuts when you're familiar with the environment. So it will speed up your process of inserting material. Of course, whenever you're uncertain, just feel free to use these drop-down menus and buttons. But my personal preference is to use keyboard shortcuts whenever I can. All right, so you realize now that I've entered a bunch of useless cells here. And one thing I realized is that this cell is now sitting above the cell I wanted to use as the first cell in the notebook. So how do I rearrange them? Well, there is a button here that has a down arrow, and this button will move selected cells downward. So for instance, in this case, I want to move this markdown cell below this markdown cell. Okay, so I can just select this cell and then hit down, so we'll move it down by 1. I can move it down by another one, another one, another one, and similarly I can go backwards by using the move the cell up. Right, so I can move it up like that. In using this tool, you can actually rearrange the cells into the order you would like. Sometimes we want to make a selection of multiple cells. For instance, I realized that I want to move these two cells together upwards by 1. The way to select them is to select one, and then hold shift on your keyboard and then click the next one and the next one and so on. And then now I'm able to move all three of them upwards or downwards as I like. I can also cut them out or delete them by selecting delete cells, and then that will remove those cells. There is a keyboard shortcut for deleting cells, and that is to select a particular cell you would like to delete and then hit D twice, and then it's gone. Of course, just like any editor, you can undo and redo some operations that I regret. So now what I can choose to do is I can select undo deleted cells, and that will return that cell I deleted back here. And just like Word or anything else, you will be able to use cut, copy, and paste. Okay. This is basically it. And these are the basic operations in Jupyter Notebook, and they will all be very useful later on. So now I think we're ready to delve in and look at this particular notebook. And in the process, we'll look at how we can make use of the Python packages that are helpful for us, and also how do we use the package SymPy, as well as how do we use Markdown to type math. Now let me delete these two cells I inserted. I'm going to hold down Shift, select one and the other, and then I'm going to hit D twice. Now they're gone. Okay, now I'm going to hit Save. I have a checkpoint that says a few seconds ago. Now we're safe to move on. All right, now let's look at a first cell here. I have some comments listed above that explains what we're trying to do in this cell below here in this code. So I said that this cell below is to import necessary packages related to SymPy and for other things we need. So for instance, in this cell here, I use first line, the third line, and the fifth line actually do not do anything. In other words, they will be sent to the Python engine, but Python engine is just going to ignore them. And the reason is they start with a pound sign. And this is essential. In coding of any programming language, it is always a good practice to annotate your code as you go along. And the reason is that after a while, it's inevitable that we will need to share our codes with someone else. Or sometimes after a while, we look back to the codes we wrote a couple of months ago and we totally forgot what we're trying to do with those codes and how we use those codes. Okay, so it becomes really useful for you to write remarks and annotations for the purposes of each particular line of code, or at least a couple of lines of codes. So for instance, in this case, the first line is being explained by this line with the pound. So these are not codes at all. They're just texts. But they're also not markdown because they won't be rendered as an output. Okay. Instead, they're just there as explanation for the code that's following it. So the first line, I said that import all functions from Python library SymPy. And that's actually what we're trying to do in line 2. Okay. In Python, you're going to see this command of import a lot. And what import does is that it's going to reach into a particular package of tools and then try to get something out of it so you can use that tool. In particular, this line says, go to SymPy, this package, think of it as, again, a bag of all kinds of different screwdrivers. And import says, go get, and star refers to everything. So in other words, we're just going to tell Python to go to the package SymPy and get all the functions from it, all the useful things in it. Okay? And we're going to pick and choose whichever one we'd like later on. Now, the third line says import another Python library. So instead of thinking about screwdrivers, now we're getting some wrenches. Okay, so we're going to get this thing called matplotlib. This is actually a very useful and a very popular plotting library in Python that's used to produce all kinds of fancy graphs. If you're into big data, this package should be very useful later on. Okay, so this line 4 here just says import matplotlib. So it just imports that. Again, just tells Python to get that package ready. Get those tools ready for us. Line 5 says that set SymPy output to print pretty math expressions. And that's this particular command that says initiating printing with a pair of brackets following it. So what it does is that it sets a particular output format for SymPy so that expressions are rendered in a very nice way. Okay. We don't really need to alter any of this. So in fact, we're just going to keep the same set of 3 lines almost throughout all of our SymPy notebooks throughout the semester because we're going to need these things. Okay. So now once these are typed in, what I can do is I can just hit Shift Return or hit Run, and then the cell is being evaluated. And once there's a number showing up in these square brackets, it indicates that the cell has been compiled. So there's no output for these because we're just telling Python to get ready. Okay, and that's totally fine. All right, moving on. Once the cell is evaluated, now we have these tools ready for us laying around, although they're not visible. But think of it as you already have these tools by your hands and we're ready to use them. So now what we're trying to do is to tell Python that we want to reserve a set of symbols that whenever we pass them on to Python, Python would know these are just some variables, some symbols. They don't actually contain any content and they should be treated as algebraic expressions just like we would in a calculus or in algebra class. In this particular case, we're going to declare there are 4 different variables we would like to use or reserve, and they are P, PB, PK, and Y. If you remember in our demand and supply class, we talked about P as notation for price, PB as a price for beef, PK as the price for chicken, and Y as the notation for income or budget of the consumer. Now, the function we would like to use to reserve these things is called symbols. And the way it uses it is that you put everything you want to declare as symbols into the brackets after symbols, and then we're going to surround them by using the the single apostrophes. Notice that this is the key that is right next to your keyboard on your right hand side, as opposed to the upper left corner key right below escape. So make sure you use the right hand side apostrophe. And it's going to be a pair of these surrounding all the notations or variables we would like to declare, and each one of them will be separated by a space. Whereas on the left hand side, we're just assigning these symbols into these things, and we're going to separate each one of these using comma. This is just a particular way SymPy takes in inputs. It's a little bit strange, but we'll just live with it because that's the way SymPy takes inputs. Every time we want to declare different symbols, all we want to do is just switch out these for the symbols we want and switch the corresponding part out on the right hand side. So there's really nothing too logical about it. It's really about filling in the blanks using the format that is demanded by SymPy. Okay, now we're going to hit run or shift enter to evaluate the cell. Now there's a number in it, it's being evaluated, and now we're all set. And now we're ready to move on to the next cell. So if you pay a little bit attention, you realize that this markdown cell is a little bit different from earlier markdown cells in that the fonts are a lot bigger and they're bold. However, the content here is still in markdown. And the reason it looks different is because I added something in the front of the text, and I added a pound sign. In markdown language, comparing to Python, a pound sign does something different from a pound sign in Python. A pound sign in markdown simply tells the language that the text following it is a title for a section. It's automatically going to bold and make the size up. So if I remove this pound sign and then evaluate it again, you can see that it just returns normal text as any other markdown cell. But now, because we want to have a nice separation between what we're trying to do next from these cells that pairing the workspace, we want to make a section and then explain what we're trying to do. So that's the use of pound sign in markdown. Now moving on to the next cell. Now you realize the text here are a little bit smaller than the one above, but they're also bold. And what happened here is I used two pound signs. So this is saying it's a subsection title as opposed to a section title, but it is not normal text. So with two pound signs, it's going to use a slightly smaller font than the section titles, but still going to set it to bold. And it's going to look different from a regular markdown cell. Now here in this markdown cell, I just typed define a demand function. And here, in the cell, first line explains what we're trying to do here. And even without reading it, just look at this particular expression here in line 2, you will realize it is very familiar. If you stare at it long enough, it is exactly the expression in the class notes, in the class slides, where we define where quantity demanded is 171 minus 20 times P plus 20 times PB plus 3 times PK plus 2Y. So what I'm trying to do here in this line is that I'm trying to write an expression with P, PB, PK, and Y, all of which are the symbols we already defined above. So now when I send this thing to Python, Python understands that the right-hand side are just a bunch of symbols. They're treated in an algebra environment. And now what I'm doing is now I'm introducing a new thing, QD, which we have not defined previously. And it is going to work as a container that says this particular expression, this particular combination of these variables is going to be called QD. In other words, we're defining a new variable or function that's called QD, and QD is going to be defined by these variables that SymPy already understood. Okay, so now once I have this line in place, I can just type QD, and when I evaluate the cell, Python is going to return to me what this QD thing is. And we can double check that it is exactly the expression we need, although the order of these terms may be shuffled around slightly. We actually don't have to put both line 2 and line 4 into the same cell. And to illustrate that, let me show you how it would look like. Let me hit keyboard shortcut B or insert a new cell below. Now in this cell, I'm just going to copy paste these contents into the cell, and I'm going to evaluate it. Now we'll see there's no output because the inputs are just being stored in QD. And now Python is just quietly recognizing that, okay, now I know what QD is. Okay, now let me insert another cell below it, and then let me just type QD. Now if I run the cell or hit Shift return again, it's going to now return the output of QD. So in fact, what we've done in the cell above is that we're combining both of these cells together. We're trying to define QD and then show QD in the same cell. So that we just need to evaluate this one cell, and then we'll be able to see the output we defined. Okay, now let me remove these two cells. Again, Shift left click to select multiple cells, hit D twice, it'll be gone. Now, with our demand function defined, we will be able to analyze it, taking derivatives, etc., using SymPy. But before we do that, we would like to do the calculations by hand first, and then document in markdown mode what would the algebra look like. So in order to do that, we will rely on latex language to help us type all this math. In the process, we will go through some essential pieces of latex you would need throughout the course in order to type algebra in the markdown. It is going to seem a little bit overwhelming at first, but it does come pretty quickly through practice. So don't freak out about it. This is not a closed book exam. There is a cheat sheet I posted on Lyceum. So what you need to do is essentially, as you work through practices and homeworks, make sure you refer back and forth between homeworks and the cheat sheet, and sometimes a little bit of Googling around and also asking questions, so that in a couple of short weeks, you will be very comfortable with typing in LaTeX and sort of see the codes as if they are just expressions. So what we'll try to achieve here is we'll try to calculate the derivative of the demand function with respect to P by hand. So first of all, before we dive in, we want to note a couple of things about the convention in typing LaTeX. So this is just a fancy notation for LaTeX. Some people like to use it. First of all, in any markdown environment, we want to distinguish between regular text and mathematical expressions that are being read by LaTeX and being compiled as mathematical expressions. So how do we tell LaTeX that this is in fact a math expression as opposed to regular text? Well, the magical symbol we need to use is the $sign. So whenever we use a $sign to surround a particular piece of text, LaTeX will treat it as mathematical text. So it's going to render it according to the rules in LaTeX. But if you do not enclose something, $signs, then it's going to treat it as text. In addition, all the $signs will come in pairs. In other words, the first $sign will be treated as the beginning of the mathematical expression, and the second $sign will be treated at the end of the mathematical expression. If you only insert odd number of $signs, it will be treated as an error. You won't be able to get the output you want. All right, the second thing that you will see repeatedly later on is that we will need to write this particular derivative sign a lot, in particular the partial derivative sign. And the LaTeX command to type that is just /partial. So partial is intuitive. That tells you this is a partial derivative. Now the backslash sign in front of partial indicates that partial should be treated not as a word, but as a particular command in LaTeX. So the backslash partial refers to specifically this particular symbol. It is a predefined thing in LaTeX. So whenever you use this, LaTeX will go and grab this thing and put it there. Okay. And another thing that's very useful is to type fractions. So what we do in LaTeX math is to use, again, frac to refer to fraction. And again, this is a predetermined object. So when I type \frac, it's going to tell LaTeX that I'm trying to write a particular fraction. And then following this fraction, I need to tell LaTeX what are the things I would like to put above the fraction and what are the things I would like to put below the fraction. And these objects will be marked by these braces. The first brace will tell LaTeX what are the things to put above the line in the fraction. And the second brace will tell LaTeX what are the things that we would like to put below the fraction. So for instance, here I wrote the derivative is partial QD over partial P is equal to -20. Can we try to write this? Well, first of all, let's look at this particular line here. It contains two major pieces. First, the derivative is colon is regular text. It is not a mathematical expression. Whereas the remaining part, the partial d partial p is equal to minus 20 thing, is a mathematical expression. So if we're going to write this in LaTeX, which part do you think we need to mark as math? That's right, it is the second part. So how do we mark it as LaTeX? Exactly, we're going to use the dollar sign to tell LaTeX this is a piece of math. Now, if we look at the expression, can you imagine how we type this thing? We would need to use a combination of fraction and partial. This is how I wrote it. Let me double click to enter the editing mode to show you the code behind it. First of all, we have a text piece that is not decorated by anything. It just says the derivative is colon. So that's our first part, which is the text piece. And then we have the second piece here, which is the LaTeX part. Now, in fact, for you to see this clearer, let me copy and paste all this code. And now let me exit the editing mode by clicking here. Let me insert a cell below, paste all this command in it. Now, if I try to run it, what would happen? Let's try. It's going to have an error. Well, why is that? Look, Python complains and says, I don't know what this is. It says invalid syntax, right? Saying that you're writing something I don't understand. But why is that? Well, it's because now we're in a code mode. So this text is being sent to Python. And of course, Python wouldn't understand this because this is not Python code. So what do we do in that case? Don't freak out. We just switch it back to markdown. And then I'm going to try to run it again, and voila. Okay, we'll be fine. So this is a regular error that you will encounter from time to time. So don't freak out about it. It doesn't mean your computer is broken, or it doesn't mean you have done something tremendously wrong. It just means that you need to pay attention to the type of the cell you use for particular code. All right, now let's compare the code that would produce this text. You can notice that this part is the text part that renders the text part. And then the remaining part, the mathematical part, is being enclosed by the pair of dollar signs. And the text in between is just the expression. Now, ignore the frac part and just focus on, let's just focus on the last part. You can see that it's really quite intuitive. I want to write equal to minus 20, and I just type equal to minus 20, and there I have it. The first part, though, is a little bit more to unpack. But again, it is just a combination of fraction and partial. So I'm going to tell LaTeX that I want to write a fraction. And then in the first brace, I want to tell LaTeX what I want to put above the fraction line. And it is a partial sign, backslash partial, QD. And that's what I put above. And below the fraction line, I'm just typing backslash partial, P. And that's what I want to write below the fraction line. And there I have it. Right? If I evaluate this cell, I'll get exactly the same expression. Not too bad, I hope. All right, now let me delete this redundant cell by again clicking D twice. And one thing I want to note is frequently when you type in Markdown or LaTeX in general, we would like to have the text blend in as part of our line of text. But some other times we would want our math to be listed as your mathematical textbooks. It's going to sit on a separate line and centered. The distinction between these two ways to display math is the following. In LaTeX, this kind of expression that are blend in to other text in the same line is called inline math. And for inline math, we're going to surround them with $1 sign. You can think of it as a simple and lighter version of math. They're just combined with text and mixed in. Whereas this type that sits on its own on a separate line and centered and brings a lot of attention is called a math display. And the only distinction between a math display and inline math is just that the signs we use to surround them is slightly different. When we want to use math display, we're just going to surround them with double dollar signs at the beginning and the end as opposed to just a single dollar sign at the beginning and the end. So for instance, we got exactly the same mathematical expression here below and above. The only distinction is that up here, we're surrounding them with using single dollar signs, whereas down here, we're surrounding them with double dollar signs. So if I remove a dollar sign at the beginning and the end, and I run the cell, it's going to be exactly the same as the expression here. It's no longer being put in the central position on a separate line. But instead, if I add the double dollar signs, it's going to render it as display math. And now it's going to sit on a separate line and centered with slightly larger font. So that's the distinction between inline math and display math. And that's the distinction between the usage of single dollar signs and double dollar signs. Instances, we want to do something like the display math, but slightly fancier, where, for instance, if we look at this output cell here, we would want to produce a multi-line equation where we're taking derivative of the demand function with respect to p, but then if we write that out in different steps, we would take derivative of this entire expression, which is the definition of quantity demanded that we have defined above. Now, if we take derivative of this entire expression, it is equivalent to taking derivative of the components that do not have p with respect to p, plus the derivative of the terms that has p with respect to p. The derivative of the first part is 0, and the derivative of the second part is minus 20, and that gives us the result. In other words, we're sort of writing it out step by step. This is a very useful technique in explaining our work and document what we're trying to do. And also, it's easy for us to identify mistakes as we go along. You will see a lot of this being used in the slides that we use in class. So how do we do this? I think a good practice is, in fact, try to type out this entire expression together. To do that, let me create a cell below the cell. So I can use insert below or hit B on my keyboard. And now, do we have a markdown cell or a code cell here? Yes, we have a code cell. So we want to convert that to a markdown cell. And I want to hit M. And now we have a markdown cell. You can see here it shows markdown. Also, there's no in here indicating this is a markdown cell. Okay, it turns out that in order to produce this kind of output, we need to use something called begin align and end align. But instead of jumping into the align environment right away, let's make use of the double dollar sign environment that we've learned and then see how it does not work. So let's try that. Let me just type double dollar sign as the beginning and double dollar sign as the end. And in between, I want to type this expression. So as a good practice, let's look at how we're going to do this. First of all, I want to type a fraction on the left-hand side. So I'm going to type frac, and then braces on the top, I'm going to type partial QD. But how do I type QD? Well, little d here is, in fact, a subscript. So let me finish the bottom of partial p here. You're going to see that the d is really big comparing to the little d here, which is a subscript that is very small. So how do we indicate that a particular letter or notation is a subscript? Well, the way to do that in LaTeX is to use underscore. So I would just type q underscore d. Now let me try to render this again. Look, now d becomes a subscript, and it's looking exactly like that. Okay, now let's keep going. We got the left-hand side term rendered, and it's exactly what we want. I want it to be equal to the derivative. Again, it's a fraction. And on the top, I only have a partial sign there, so that's it. On the bottom, I have partial p again. And now, I'm taking derivative of this entire expression surrounded by the brackets. So I have the brackets here. Now I have 171 minus 20p plus 20pb, but now b is a subscript, so I'm going to use underscore, plus 3p, pk, so again, it's underscore k, so I'm going to type that, plus 2y. Now let me try to render this. That's exactly what we want to have. So what we've learned at this point is that to type subscripts, we'll just use underscore before the subscript we want to use. All right. Now, notice how we have the first line already, and now let's turn to type the second line. So how do we do that? Well, the math display environment surrounded by the double dollar signs do not allow us to have line breaks in between. Moreover, any kind of spaces in between actually do not get rendered. For instance, I can add many spaces here and the outcome will be exactly the same. There will be no change at all. So all the spacing between letters and numbers are taken care of by LaTeX automatically in the math environment. So it always looks nice. And this is part of the reason why typing LaTeX is so easy and relatively struggle-free once you get the hang of it. All right, so we've been talking about there's no line break in math display. So how do we type the second line? Well, you're going to say, let me just start another display here. So why don't we try that? So now let me try to write the second line, which is equal to, again, now let me take a fraction, braces, indicating the top and the bottom. Top, we have partial, on the bottom, we have partial p, and then again, parentheses 171 plus 20 p underscore b plus 3 p underscore k plus 2y. Okay, and then the second term, plus sign, and then another fraction here, braces, on the top, partial, on the bottom, partial p, and now parentheses again, minus 20p. That's it. Well, see, if I render the result, it kind of looks okay, in the sense that the contents are exactly the contents we want. However, the formatting is off. You can see that the equal sign isn't really lined up with the equal sign here, and it becomes a little bit awkward to read. We want to signal to the readers that as we write these equations one after another, it is a natural development that is derived from the previous step. So we would want these equal signs to line up. In other words, we would want them to be aligned. Okay. However, the math display environment does not allow us to take line breaks. When we type these two equations in two separate math display environments, they're being treated separately. So there's no way you can tell LaTeX to line them up. This is the reason we want to use an alternative, which is to use this align environment that essentially tells LaTeX that what we're typing isn't multiple equations, but instead is one equation that has many, many different lines, and they need to be lined up at a particular point. Now let's try to edit the two equation math displays we typed in into an align environment. So to use align, what we would do is that we're going to treat both of these lines as the same equation. So instead of typing double dollar signs at the beginning and the end of every equation, we're going to remove them. Of course, now if I evaluate it, it will just turn into text and won't turn into math. So now I need to wrap all this stuff around in an environment such that the LaTeX will recognize that it is actually a part of LaTeX math, and therefore it will be processed as such. So to do that, the environment we use is called align. So I'm going to type begin align before we type anything, and then I'm going to type and align. So that marks the beginning and the end of all these equations. So that's the first piece. Now LaTeX understands that this is a math environment. So now, in fact, if I just render it, you can see that it is being displayed as if we just have a math display here. Okay, so we're halfway there now. The remaining step is that we need to tell LaTeX that we want a line break at this point. Right? So now let's try that. The way to tell LaTeX that we're actually giving a line break at this point is to use the double backslash sign. And this is the line break symbol in LaTeX. Now if I render it again, you can see that we have a line break. But then you might say, whoops, we're back in square one. It's just as if we use two math display equations, but that's actually not true. as long as we tell LaTeX how to align these two equations. Okay, we want to signal to LaTeX that we want them to be lined up at these equal signs. So how do I signal LaTeX about that? Well, the sign to use is this and sign. Okay, so if I just type and sign, or I hold Shift and press 7, then LaTeX understands that the contents after this point is to be separated from the contents before it. And for each and every equation that is separated by a line break, I want to tell LaTeX that which part is the one that we want to be treated as a second component of the equation. So here in the second equation, I want everything to be treated as the second part, as if they are the second part of the first equation. So here, let me just type the and sign again, and let me render that. Voila. Okay, now we're almost there. How do we write down the final answer in the third line? Can you think about that? You probably already thought about the solution. Well, the way to do that is to add another line break so that LaTeX understands that we're in a third equation. And the third equation we have is equal to minus 20. That's it. And the remaining part is just to tell LaTeX that we need to line up this equal sign with this equal sign and this equal sign. So to do that, I'm just going to add an and sign here, and we should be all set. And this is exactly how we type this sort of multi-line equation. And this is by using the align environment. We use begin align to mark the beginning and end align to mark the end to surround all the equations we want to type. We're going to use the double backslash sign to signal the line break between each equation. And then we're going to use the and sign on each line to tell LaTeX where we'd like the equations to align. And that's it. Basically, these are most components of the LaTeX math you need to understand for this entire course. You will inevitably run into something you might want to type and didn't know how to. And there is a very extensive LaTeX math cheat sheet I posted on Lyceum. And here you can find about the basics of how to type almost everything. So for instance, to type squared, type the superscripts, we'll just use this sign here instead of the underscore, where underscore types subscripts, the sign here types the superscripts, right? And sqrt types the square roots. We already learned about frac, and you can write these fancy mathematical letters. For Greek letters, alpha is alpha, backslash beta is beta, backslash gamma is gamma, backslash delta is delta, etc., etc. So you have a full list of these things. You can write these fancy notations, where some of them we might use later on. You can use decorations, dot, double dot, hat, etc., etc. All right, we can even write integrals and sums very easily. So whenever you run into some issues, come back and check this cheat sheet, see if it provides the answer you need. Feel free to discuss with your friends, your peers, and me, and our TAs about questions you might have. And again, always Google. So many people have run into similar problems before. It's more likely than not that you're going to find the answer just by Googling it. All right, that's pretty much what we want to introduce you to up to this point about LaTeX math in Markdown.